changing from the old distribution to the new distribution, where you can really clearly see the distinction between the two and why this repaired distribution is better. I'll run that animation here again in case you didn't catch it. You can see that the revised distribution is clearly much more normal. Okay, so now at this point we've got a solid quality risk analysis document, and it's a good basis for testing. So at this point, Test Manager is going off to align the testing with risk. So one of the things that he did was he goes through the risk items and he goes through the specifications. Specifically, he had a product requirement specification and a detailed design specification. Now, the way you do this is you go through and you review the requirements spec and the design spec, basically any specs that you've got, section by section, and you check to see that there's a corresponding risk item. You should be able to capture traceability of the specification to a risk item. If you've got a specification element that doesn't correspond to a risk item, that's probably a hole in your risk analysis, because there's always a risk that something could go wrong. Now, some sections of the specification, like an introduction or something, may not map to a risk item, but the main body of the specification really should. So if you find any risk items that, or any specification elements that don't have risk items, you want to add a risk item for that. You want to capture traceability between the risk items and the specifications, and that's going to be helpful to you if/when the specifications change, and you can go through and rather than have to review all 100 to 200 risk items and see how the change to the specifications affects the risk items, you just look at the risk items that relate to that particular specification element. Now, it's not necessarily the case that every risk item has to map to a specification element. Every specification element should map to a risk item, or otherwise there's a hole, but sometimes you'll find risk items that don't necessarily map to specifications. Now, you could say, well, that's an issue where the specifications are incomplete, and that might very well be the case. Something you could escalate as a byproduct to project team to see if they want to address that. But you know, that's not unusual, and I wouldn't worry about it too terribly much. Just capture that fact that you've identified a risk that doesn't map to a specification and escalate that to the designers and business analysts and so forth. Now, map the risk items to the test cases. This is something you'll need to do if you do have an existing set of test cases. If you're working on a what's called a greenfield project where everything is brand new, then there won't be any existing test cases to map the risk to. But most of us have existing test cases, and you need to map the risk items to the test cases. And you know, you might very well find that there are risk items that don't have test cases for them, and if they're sufficiently high risk that they need to be tested, then that's potentially a problem. You need to add tests. Now, what you'll want to do is evaluate and reallocate your testing effort overall based on the level of risk, and I'll talk in a minute about how we did that. And then propagate the risk priority numbers of the risk items down into the test cases associated with them, and that's going to allow you to sequence your test cases, and also, again, if you have to triage them, then you'll be able to use that. Okay. Oops, pardon me. Got one slide ahead of myself there. Now, this is the effort allocation table for this particular project that shows the mapping of the risk priority number ranges to the extent of testing. So basically, any risk item that had a risk priority number between 1 and 12 was going to get extensively tested. 13 to 16 gets broad testing, 17 to 20 gets cursory testing, and 21 to 25 gets opportunistic testing. There's another extensive testing that's commonly used, which is report bugs only, which is not on here, which basically would be that if you found you would not do any testing against that risk item, but if you found a bug related to it, you would report it. Now, you can see over here in the comments an explanation of the different extensive testing other than the report bugs only. But what I want to do is just try to illustrate these actually with an example that might complement the description that you see on the slide here. Let's suppose that you are testing a word processing application like Microsoft Word, and you've identified a risk in the area of functionality, fails to open supported file. Now, Word can open a lot of different types of files, and there are a lot of object types that can occur in a file. It's not just text, but it can be pictures and tables and headers and footers and different fonts and so on and so forth. So there's a lot of object types and a lot of file types. Now, you say you want to do extensive testing for that risk item. Then you'd be saying that you want to make sure that you test every supported file type, and within every supported file type, every object type supported for that file type. So in other words, combinational types of testing. So that tends to be an expensive proposition, but if you say it's high risk, then that's what you need to do. Now, broad testing, you would say, no, I'm going to run every supported file type, and I'm going to test every supported file type, and I'm going to test every supported object type, but not combinations. I'm just going to make sure that every supported object type occurs at least once in some supported file type. Cursory, you'd say, well, I'm not even going to do that. I'm just going to select the most important file types, the most important object types, and I'm going to test those. And then opportunity, you would say, you know what, I'm not going to create any test specifically to test this, but I'm going to look for opportunities to exercise some file open functionality as part of testing something else. It's going to be a small and incremental investment. And then report bugs only, which I'm not showing here, but if you had that defined, then that would mean that you would not do any testing at all for this file open capability. But if you did see a file open bug in the course of testing something else, you would report it. Okay, so you can see this is the effort allocation table that they've got here, and I'll just point out the risk priority numbers associated with extensive testing. This is a pretty broad range, and you might say, wow, well that's really, they're going to do a lot of testing, and that's true, but this is a data center utility that really pretty much has to work in order for a data center to stay up. There's some pretty significant problems that are associated with this utility not working. So it's this kind of effort allocation is appropriate to the overall business risk associated with that application. Now, we got a finalized risk item, risk priority number, and effort and test case, traceability, and so forth. So the test manager then prioritized the test cases based on the risk priority number, as I mentioned. And Jim, the test manager, told me that created some fairly significant changes from the older purely requirements-based approach. Before, what had happened a lot was that the tests were assigned to testers based on their experience, like who's the most qualified to run this test. Well, what ended up happening was you had a handful of people who were like the key players, had the most experience, and of course they ended up getting most of the tests assigned to them. Unfortunately, and not just most of the tests, but almost all the important tests. So what that ended up doing was delaying running of important tests, and thus the discovery of important bugs, till really late in the project. So what the insight that Jim got from this risk-based testing was, well, don't do that. You want to sequence the test based on risk, and look for some ways to get more creative about who runs what when. And that then changed the way that the tests were run, and the higher priority tests were run much earlier, lower priority ones later, and that with a consequent effect on bug finding. They also drove risk-based testing into their bug management process, so they started to augment their severity rankings with the risk prioritization of the test that had identified the bug, which is a creative thing to do. And then, when there are high-risk problems, they focus their bug fix efforts on that. Okay, so at the end of the project, we did a retrospective discussion, and what are the benefits and what are the key lessons learned from this pilot project. And in terms of benefits, they felt that they got an intelligent effort allocation within their constraints, that they did achieve the priority order bug discovery, and then optimized the bug fix time available for each bug based on